the IPCC, talking about how to register as an expert reviewer for the upcoming IPCC second order draft, especially for the Africa chapter, where we would welcome a diversity of experience and expertise in commenting on the work we've done. Then, separate from the IPCC, we will be presenting 5 short research talks. Each one will be about 10 minutes. There will be some 5 minutes or so for questions at the end of a research talk. Please keep your questions short if you're asking them verbally, and use the raise hand function in the Zoom chat to do that. As the moderators, we will then just name 2 people to ask questions. Again, please keep them short. But also, if you have further questions or comments, please use the chat box. All of our presenters and others on the call will be responding to questions or comments or requests for clarification in the chat box throughout the call. That also includes Andrew around anyone with questions about being an expert reviewer for IPCC. So please use those, and as hosts, we will be monitoring them. So we're going to start with how to register as an expert reviewer for IPCC, and then move on to the research talks as outlined in the program here. Once again, thanks so much, everyone. I'm really looking forward to this, and I hope we all learn a lot together today. So with that, Andrew, over to you.
Thanks, Chris. I'm going to share my presentation quickly, and then take you through it.
Great.
Okay. Yeah. Can you see my screen?
Not yet.
Not yet.
There we go. It's up.
Right. So good afternoon, and thanks for this opportunity. Before I take you through the expert review process, I will quickly take you through the IPCC so that we understand where the expert reviewers are situated. So the Intergovernmental Panel on Climate Change was established in 1988 by WMO and United Nations Environment. And its primary role is to assess scientific, technical, and socioeconomic information and provide policymakers with an objective source of information about the risks and causes of human-induced climate change, potential environmental and socioeconomic impacts of climate change, and then lastly, the possible response options to climate change. It is important to note that IPCC does not do research. Rather, it assesses evidence in form of peer-reviewed literature or gray literature that is out there. And also the IPCC produces policy-relevant but not policy-prescriptive information or report. The IPCC is made up of 195 member states. It has 3 working groups and a task force on national greenhouse gas inventories. And these combined coordinate and assess and oversee the assessment process of the IPCC. And then we have international scientists and experts in form of authors, contributing authors, and reviewers. So the cycle of the IPCC report in short starts with the internal draft, which is reviewed by invited expert reviewers. And then we will have the first order draft, which is reviewed by experts. Anyone from around the world can register and review the report. The first order draft of the working group 2 report was reviewed between December and January of last year and January this year. And once that is done, a second order draft is prepared together with the summary for policymakers, which is reviewed by government and experts, and that is what is going to be available from tomorrow. Authors then prepare the final drafts of the report and the summary for policymakers. These are then sent to governments, and then the government review these in preparation for the approval plenary. At the approval plenary, the panel, which is the 195 governments, they go through the summary for policymakers line by line and approve. And then once the summary for policymakers is approved, the underlying chapters gets accepted. So the expert review is an essential part of the IPCC process. It ensures the highest standards of scientific excellence, clarity, and balance. It encompasses a wide range of views, expertise, and geographical representation. There's also a possibility of group reviews. So for instance, if you work at a research center or in a lab and you have a group of scholars and postgraduate students, and you want to review the report as a group, you can contact us and we'll take you through that process. So what do you review? The report is quite big, so you can choose to review a chapter, a section, a topic, or as Chris was talking about, you can choose to review, for example, the Africa chapter. Your comment should be ideally formal, it should be polite, constructive and helpful, especially considering that our authors are volunteering their time. So please provide comments that is going to be helpful. You could also look at statements, observations, make suggestions, contents that you are not clear about, request for clarification. You can comment on whether the figures and tables are understandable or if they are appropriate. And look at whether the executive summary convey key relevant policy messages. And finally, please note that the finished product will be copy edited. So do not focus on editorial issues. And also note that each comment you provide, the authors will have to respond to them. So if you provide 1,000 editorial comments, the authors will spend time responding to each of those editorial comments about missing commas and spelling mistakes. So we'd rather request that you focus on constructive, substantive comments. So when you are reviewing the report, you could look out for how the contents cover issues. You could compare the approved outline with the report and see if there are gaps. Look for factual accuracy or inaccuracies, and how topics are handled, are there biases. Look out for important policy relevant conclusions. Also look out for possible missing references. But please note the intention is not to cite every reference on every issue that is out there, but check if important references on any issue is missing, point that out to the authors and they will really appreciate it. You could also look at the structure, the comprehensiveness, how issues are treated across the different chapters in terms of balance. And remember that your voice is important. You may know things that nobody else knows. You may also know of important regional literature that is not yet included in the draft report. Be bold, share what you know with the authors and they will appreciate it. How do you register as an expert reviewer? Go to ipcc.ch and then click on news. You will scroll down to the options where you see the press release on the second order draft. Go to explore, scroll down again to where you would see options to register. And once you click on that, you will be given this window interface where you choose the product or the chapter that you want to review. Ideally, you should select all of them because in the process of reviewing the report, you might come across a situation where the chapter that you are reviewing or the section you are reviewing cross-reference another chapter and you might want to go to that chapter to see what is being referenced. So ideally, select all of them. You'll be asked to provide personal details, complete that. And then you'll be asked to provide a list of publications, a maximum of 5 and a minimum of 1. You have to impute the security information to indicate that you're not a robot. And then finally, you sign the declaration. And once you do that, your request to review goes to the technical support unit. They will assess it and give you approval. You will receive an email with a personalized login details, which you would use to assess the draft report. Please note that the report is still in draft stage and they are not supposed to be referenced or shared with anyone. Each product you download comes with a personalized barcode. You will also have access to an Excel file that you will complete your comment. The first sheet of the file has an instruction on how to complete the review. In the second sheet, you have this interface where you can choose the chapter that you want to comment on, or if it's a summary for policymaker or the technical summary. You choose the start page and the end page. You choose the start line and the end line. Very important to have this ordered correctly. Otherwise, when you want to upload your comment, the system will reject it. You will then choose the category, whether it is text or a figure or table, and then you put in your comment here. If you don't complete this correctly, you will notice that the row will remain red. Once you've completed your comment, you use the link that you received to upload your comments. You should ensure that your comments are uploaded on or before January 29, which is the cutoff date. Anything after that will not be considered. And as I said, uploads with incorrect page numbers will be automatically rejected by the system. And you have to go back, correct it before you can upload. When the report is finalized and everything is approved, your comments, together with how authors respond to the comments, will be published, and your name will be acknowledged as a reviewer who contributed to the production of this report. So thank you very much for your time. If you have any question, you can contact the technical support unit email, or you can write to me and we will attend to your question or your comment. Thank you.
Thank you, Andrew. Thank you very much for that informative presentation. I hope many of you will register as reviewers for the IPCC, for the Africa chapter, and also for other chapters that fit your expertise. Andrew, you will also be helping in the chat. If people have questions about reviewing, please put those in the chat and Andrew can steer you in the right direction. I'll hand over now to Portia Adade Williams, who is our first research presenter. Thanks again, Andrew.
Thank you, Chris. I hope I'm audible.
Yes, we can hear you.
I'll share my screen shortly. Good day, everyone. I'm Portia Adade Williams. I'm a research scientist with the Council for Scientific and Industrial Research in Ghana. My talk today is on a study we conducted, myself together with other researchers across the continent, on the feasibility and effectiveness of climate change adaptation options in Africa, from which an output is actually included in the upcoming state assessment report of the IPCC. My talk will follow this outline. So as way of introduction into the study, climate adaptation is both an urgent and important development agenda for Africa. And in choosing and allocating scarce resources for either mitigation or adaptation options, there is the need for robust evidence. And over the past decade, literature on climate adaptation has really grown in Africa, but there hasn't been any systematic assessment of the feasibility and effectiveness of the options that are identified. So our study assessed feasibility of 24 promising adaptation options within the African context. How did we do it? For the interest of time, I will refer definitions of adaptation, feasibility, effectiveness to the IPCC Fit Assessment Report and also to the 1.5-degree special report. For effectiveness, we also adapted a study from Owen in 2020, which looked at what makes climate adaptation effective, a systematic review of literature. So for the context and for the purpose of this presentation, we looked at 24 observed adaptation options. And how did we identify them? We did that iteratively through a review process, which included looking at options within the IPCC special reports on global warming of 1.5 degrees. We also conducted an extensive desk review. And also we consulted some experts. And we did all that to cluster 24 adaptation options. And as seen in table 1, we had over 100 specific strategies across 6 priority sectors. I'll touch on the priority sectors shortly, but then the options in red are the main adaptation options that we considered for this study. In developing a framework, we adapted approaches from SIN and others, and also on Owen. We did some modification of their framework. It was through a multidimensional assessment approach, where we used 6 dimensions. Thus, we considered economic, environmental, social, and institutional, technological, and potential risk reduction. Table 2 is just showing some examples of the dimensions and indicators we used. The column on status of indicator gives indication of whether the dimension or indicator is new, or maybe we did a modification or it's already existing. So the sectors that we also considered were food, health, water, cities, poverty, and then ecosystem. And the sectors were also selected because they align with the sectoral framing of IPCC, and also aligns with some stated sectoral priorities for within the African context. So considering SIN and other 6 dimensions and 19 indicators, after we did the modification, we had 6 dimensions and 16 indicators. And then we also modified the guiding questions. The indicators for feasibility were from SIN and others, and that for effectiveness was from Owen. And our focus mainly was to look out for presence or absence of barriers to adaptation responses, and then evidence to potential risk reduction. So all the modifications were made specifically within the African context. So on the design, our main data source was from the Global Adaptation Mapping Initiative, which is GAMI. It's an initiative that provides data on global stocktake of human adaptation-related responses. That has been documented in literature between July 2013 and 2020. It provides a broad coverage of existing adaptation measures, and we followed a multi-stage assessment. By that, I mean that from GAMI, we had 518 studies from Africa. We selected and segregated that according to the sectors that we considered. Also, the studies were then mapped to options. And then through that process, we excluded 80 studies. We excluded them because they probably did not fit any of the 24 categories of options we were considering, or they were not explicit on specific options that were mentioned, or whether the variable indicators we were looking for were not having adequate information for that. So in total, 438 studies were finally considered for the actual assessment. And in that, we actually extracted information to show whether an indicator was a hindrance or a barrier to the feasibility and effectiveness of an option. During the analysis, an option was to be included if it had 2 or more papers. And depending on the ability for a option to block the feasibility, we rated as either A, B, or C. So if it could potentially block the feasibility, it's an A, or if it's somewhat blocking it, it's an B. We followed that process. And from that, dimensions were then grouped to show whether it had significant, medium, or insignificant barriers, which we termed as low, medium, or high feasibility. And that was done by assessing the average of all effective indicators. To some findings, Figure 1 is actually showing country-level representation of all options that were mentioned in literature across the African context. We had countries like Ghana, Nigeria, we had Ethiopia, Kenya, Malawi, Tanzania, and South Africa having most mentions in adaptation literature. I'll jump to Figure C, which is showing a distribution of the mentions by regions. And West Africa dominates mentions, followed by East Africa and South Africa. We have North and Central Africa having least mentions, which is already depicting a gap. By far, moving to Figure B, by far the greatest number of reported adaptation options were in food sector, especially for Ethiopia and Ghana. We had South Africa also having highest number of observed adaptation actions that were related to cities. We also had water-related options being observed in Kenya. And for health, we had Ghana and Nigeria also coming up prominently. This is showing the number of studies of adaptation options per sector. This one is just related to the studies. And individual studies frequently reported multiple adaptation options. We have about 50% of the studies that we reviewed coming from the food sector. And this was followed by poverty, then water, health, cities, and ecosystem. A large number of the studies also were focused on sustainable water responses. We also had sustainable agri practices. We had crop management and agroforestry also having very high number of studies. But then studies related to climate information services and financial investments and fisheries management also were very limiting. It's had less than 10 studies. And it's also here showing another knowledge gap. And though it is low in Africa, we saw that it's also kind of emerging. Table 3 here is giving an overview of the assessments that was done. Importantly, this study was actually serving as a guide to dimensions and indicators to consider and in choosing or committing to adaptation response. So all the options that we assessed actually had some level of feasibility in at least one of the dimensions. Some options within the food sector, like crop management and agroforestry, were showing moderate feasibility across 3 or more of the dimensions. Apart from like 2 options within the technological dimension, we saw that studies across Africa in terms of technological feasibility was very low. And it cautions us on the importance of considering technological availability of options when we are doing policy planning. Institutional aspect also came out. It was revealed that it's also having low feasibility. We also identified some kind of synergies and trade-offs with the studies that we considered. For example, for sustainable water management, it has potential to improve food security, and of course, it also improves crop productivity. But then there were trade-offs with exploitation of environmental resources, such as deteriorating water quality, and sometimes conflicts were also reported. Quickly to conclude, what are we saying? Our study built on Sin and Owen's study. It came up with some indicators and dimensions that are relevant and credible for uptake at other geographical settings. If once it had appropriate context and there is evidence existing. The assessment also brings out some complexities in adaptation practice, that some options might show low feasibility. It might have many barriers to it, but then it might be desirable within a specified local context, which brings in context as a key consideration when you are considering feasibility of adaptation options. Also, there are gaps in both knowledge and practice of adaptation, feasibility, and effectiveness in Africa that is persistent, and future studies could build on them. So this is just to say we have a manuscript that's come up on evidence-based feasibility assessment on adaptation options in Africa with environmental research letters. This is to show the team of researchers who worked on this study from across the continent. Thank you.
Thank you so much, Portia. We have time for one question if someone wants to ask a question over the microphone. Otherwise, in the chat is also fine. I see there's some in the chat. But if anyone would like to ask a question for Portia, we have a few minutes. I see Belinda Petrie. Yes.
Thanks very much, and thanks, Portia. I just wondered if you could make a comment around the adaptation options, the 24 that you were talking about, around additionality. I'm personally not arguing that these are are important adaptation solutions in Africa, but I just wondered if the extent to which you thought about the additionality issue around, in other words, climate change additionality on top of the development imperative for many of these solutions. Thanks.
Sorry, please come again. It's breaking up a bit here for me.
Sorry, Portia. Can you hear me now?
I can.
Okay, great.
Yeah.
I'm happy to repeat. I was wondering around these 24 adaptation options, all of which make complete sense in terms of being important solutions for Africa. I just wondered whether or not this work has looked at the additionality question. Many of these initiatives could be considered as business as usual. And, you know, such as bulk water infrastructure, for example, among others. And so I just wondered what your thoughts are on the climate change additionality question. Thanks.
Okay, so if I heard you very well, it's still breaking up a little here for me, but it's on additionality of the adaptation options. Yes, like
Yes.
Chris. Hello, Chris.
No, Portia, that's correct. You understood correctly.
Okay, if it's on, yeah. So on additionalities, these are not, these were pulled out from iteratively, like I initially mentioned, from studies across Africa between 2013 and 2020. And there are a number of specific options, over 100 that were identified so these 24 are the clusters that we had, and there are a number of, so from table 1, sorry. Yeah, so a number of options that were related to specific, so we did a clustering. So additions could be made up from these 24 options. There could be additional ones, but then we had an exhaustive list of
Portia, I think we might be losing you.
Yeah.
I think, unfortunately, for time reasons, we're going to have to move to Nick. But Belinda and Portia, there is the chat function. And I see Adunya and some others have asked questions about the presentation as well. So if we could move the conversation to the chat, that would be great. I'm sorry about the connectivity on that side. Okay, next up we have Nick Simpson, who will be presenting on climate change literacy. Portia, thank you so much for that thought-provoking presentation.
Hi everyone, can you see my screen all right?
Yes.
So I'll be sharing some work that we've been doing on climate change literacy in Africa. Although we have a growing idea of climate change perception and climate change awareness across the continent, much of those studies have been very local and few have looked at nationally representative studies. Further, we know less about climate change literacy across Africa. So a bunch of us decided to do a continental study of this and try get a handle on where Africa is for climate change literacy. Across Europe and North America, climate change literacy is commonly above 80%. But at a national level, in Africa, it ranges between 23 and 66%. So here, using a meta review and data from the Afrobarometer, the largest public opinion survey in Africa. I'm going to talk you through our assessment of national and subnational level climate change literacy rates and the factors associated with climate change literacy on the continent. So what are the drivers, the predictors of climate change literacy? Why is this study important? Well, the majority of our understanding of responses to climate change on the continent are very focused on how people perceive changes in their weather or meteorological changes, but those perceptions are not necessarily a perception of climate change as understood to have a human role. Rather than looking at perception or having just heard of climate change, we hypothesized that having an understanding of the role human activity plays in causing climate change would have a very different response to our perception, our understanding, our experience of the climatic changes happening on the continent. This is largely because observed adaptation responses to what is perceived climatologically or meteorologically is commonly behavioral and often lacks the substantive or transformative types of adaptation that projected risks for the continent would require. So our hypothesis behind this study was we need climate change literacy in order to have a commensurate response to the scale of risk coming over the next 10, 20, 50 years on the continent. So we first did 2 meta-reviews of climate change awareness and climate change perception on the continent, where for every country, we looked for studies in Web of Science and Google Scholar that would indicate drivers of climate change awareness first. And as you can see, education is a strong driver of climate change awareness, social engagement is a strong driver, exposure to radio and TV. If you're male, you're more likely to be climate change aware in Africa. Age, income, experience, contact with an NGO or extension officer, and urbanization are all commonly recorded drivers or predictors of climate change awareness in the continent. And South Africa, Nigeria, Tanzania, Zimbabwe, Ghana dominate studies in the peer-reviewed literature around climate change awareness. For climate change perception, the picture's a little bit different, which speaks to our hypothesis, because there's a vast number of studies looking at how people have perceived meteorological and climatic changes, but those perceptions of temperature or rainfall changes or other environmental changes that they link to the climate aren't necessarily a perception of anthropogenic climate change. So what did we find? We found climate change literacy vary substantially at both country and subnational levels across the continent. For example, climate change literacy rates in Mauritius are 66%, Uganda 62%, but in Mozambique only 25%, and in Tunisia only 23%. We found no correlation between country level climate change literacy and the country level index of climate change vulnerability. Being able to compare subnational administrative units across Africa shows that for 394 subnational regions that were surveyed by the Afrobarometer, 8% of these regions have a climate change literacy rate of lower than 20%. While only 2% of these regions, or 8 regions, score higher than 80%, which is the norm for Europe and North America. And striking differences exist between when comparing subnational units. For example, in Nigeria, Kwara State has a climate change literacy rate of 71%, while Kano State only 5%. In Botswana, Lobatse, it has a climate change literacy rate of 69%, and Kwaneng West only 6%. The average range between the highest and the lowest climate change literacy rates at subnational units is 33%, indicating a high range across countries and within countries. Since the Afrobarometer is geolocated, we were able to, using climate reanalysis products, identify the experienced climate trends of each of the survey respondents. So there were 44,600 survey respondents that informed this climate change literacy study. And so we were able to determine the annual number of extreme temperature events that those respondents experienced over the last 30 years, the annual number of heavy precipitation events they experienced over the last 30 years, showing whether there was an increase, decrease, or significant increase or significant decrease, as well as no change for these three metrics, as well as the annual number of severe and extreme drought events that were experienced by the participants. This is important because the Afrobarometer asked a question around survey respondents' perception of changes in their climate. And we were able to look at the relationship between their perception and their actual experienced climate and see whether those had any bearing on their climate change literacy. So what did we find? We found multiple socio-demographic characteristics play an important role in climate change literacy. Education was the strongest predictor, which is consistent with some previous work as well as other studies on climate change awareness. Gender is also an important predictor where you are much more likely to be climate change literate in Africa if you are male. Urbanization drives climate change literacy, and poverty undermines climate change literacy. Being more mobile and more socially engaged, more politically engaged, is a high predictor of climate change literacy on the continent, and perception of drought is a predictor of climate change literacy. We were surprised to find that experience of disaster events, climatological, hydrological, and meteorological at a national level had very little effect on predictors of climate change literacy. But, and this is the first time any studies found this, we identified the effect of 10-year changes in precipitation, temperature, and drought to have an effect on climate change literacy. There was less of an effect at the 30-year historical range. So what does all this mean? This study emphasizes the high variability of climate change literacy across the continent, as well as the importance of particular socio-demographic and environmental predictors of climate change literacy. Given that Africa is projected to undergo substantial shifts in urbanization, education, gender equality, mobility, and income in the near future, progress towards these sustainable development goals are likely to yield co-benefits for climate change literacy, and therefore are potential response to climate change that would be more commensurate with the levels of risk anticipated by future global warming levels. Thank you.
Thanks very much, Nick. Again, we have time for one question. If someone would like to raise a hand or ask a question, otherwise also the chat, they can answer questions in the chat. Thanks, Nick, for that talk.
Hi, everyone. Hi, Nick. Thank you for the amazing presentation. My name is Gugu Nonjinge. I used to work for the Afrobarometer in the past few months. I just wanted to ask you, based on the research that you've raised, and also maybe this could just not necessarily be based on the numbers themselves, but also on your personal opinion, if you think that South Africa, because I know that in South Africa there's only probably 40% of the people who only even know what climate change is. Do we think that we can move to a point where we have a population that understands climate change? Because in order for us to be able to tackle climate change, we need to be able to start at the literacy level. Do you think that's possible?
Yeah, that's such a fantastic question, hey, because as I showed the regression results, secondary high school and post-secondary high school, so if you've got a tertiary education of some sort, those were like by far the largest influence on climate change literacy. So investments in education can have co-benefits for climate change literacy. Across the continent, though, it's such a diverse effect, and so we did have a look at potential correlations between general literacy rates as they were most recently measured and climate change literacy. And it's not super straightforward for all countries that literacy equates to climate change literacy. But in the whole, and for South Africa, yes, the benefit would be there for that future. Yeah.
Okay, thanks so much, Nick. If others have questions, please put them in the chat for Nick. I can see that Portia and about the previous talk, there's a good discussion going on. So please ask questions from Nick in the chat about the data or the methods or anything else to do with the presentation. Nick, thanks so much. We'll move on to the next speaker. Okay, hi everyone. I'm Chris Tresos from ACDI and the Climate Risk Lab, and I'll be presenting about finance for climate change adaptation and research in Africa. This work was done with a range of colleagues from ACDI, as well as the Stockholm Environment Institute and the Norwegian Institute of Environmental International Affairs, and it was helped with support from IDRC and the FCDO. So we know from previous global studies that adaptation projects are expected to be cost effective, with benefit cost ratios in the range of 2 to 1 or 10 to 1. So that's sort of $10 return for $1 spent. And many African countries express a stronger demand for adaptation finance than for mitigation. So a study of 16 African countries found a demand ratio of about $2 to $1 for adaptation to mitigation finance requested. So this research that we undertook was to really map climate finance flows in recent history between adaptation and mitigation across Africa and also between countries. We found that US dollars, about 49.9 billion, has been committed to climate-related finance in Africa since 2014. This is reporting to the OECD from bilateral and multilateral funding sources. Less than half of this, around 19.2 billion, was earmarked for adaptation activities. This includes some amount that is for a mix of adaptation and mitigation initiatives, where both of those are a goal of a funding project. The amount for adaptation is equivalent to about $3.8 billion per year across Africa. And this is well below the estimates of what adaptation costs are expected to be around 2020 for the current amounts of climate change we have, which range from 7 in the low end. So we're at about half of the low end of the estimation is being committed. And of the finance committed to adaptation, more of it is through debt finance, or debt instruments than grants. So 42% of adaptation-related finance was grants, and 57% came as debt, so loans with interest repayments. This is the picture of how that finance is distributed across the continent. Yellow here shows the proportion to adaptation, and brown and orange to mitigation. So you can see the total finance is split between adaptation and mitigation, varies a lot at the country level. South Africa and Egypt, for example, get a lot of finance, but this is mostly for mitigation. Uganda, by contrast, has also had a fairly substantial amount, mostly for adaptation. Countries along the west coast of Africa, from Namibia up through to Mauritania, have had much less, and a lot of that has been for mitigation, with the exception of Angola that has a lot for adaptation. So there's a large variance across the continent. Many countries that have received more financing, like South Africa, Egypt, Morocco, more of that has gone to mitigation. Of concern, and this is quite troubling, there's a very low funding disbursement ratio. So what I've showed you up to now was commitments, but rather than commitments, what really matters for action on the ground often is the amount of finance that's actually dispersed and paid out. And so we found that for all funders, excluding multilateral development banks like the World Bank, for which disbursement data is not available, total disbursements of adaptation finance between 2014 and 2018 summed to only 46% of the total that was committed or promised. This ratio is extremely low. North Africa fares the worst, with only 15% of committed finance actually dispersed, followed by Central Africa and West Africa. And apart from Southern Africa, all the subregions of Africa compare really poorly with the global disbursement ratio for adaptation finance over the same period, which is 51%. So you can see in the top charts here that for mitigation and for adaptation, African countries have a lower disbursement ratio than the global disbursement ratio rates. But in general, climate compared to total overall development financing is much lower. So this suggests, when you look at that total development financing disbursement ratio, Africa actually outperforms the global average. 97% of what is committed is ultimately paid out, whereas adaptation is especially low here at only 37%. So this suggests that there might be some problems particular to adaptation projects and their implementation that is holding back that funding. Next, we looked at funding for climate research on and in Africa. And so this is an analysis of around $1.5 trillion of research grants for all fields of research across 521 funding organizations globally from 1990 to 2020. And the first finding is that as a proportion of total research funding for Africa, climate change research funding has been growing over the last 30 years, and it's currently around 5% of the total research funding on Africa. However, institutions in the United States, the United Kingdom, and Europe receive hundreds of millions of dollars more in funding for climate change research on Africa compared to institutions that are based on the continent. And so these bar charts are showing that. On the left, you're seeing countries financing climate change on Africa. So most of the financing for climate change research on Africa is coming from the United Kingdom. Belgium there is highlighted because that's where the European Union is headquartered, so that includes the EU financing. Then the United States, Germany, Sweden, the major funders of climate change research on Africa. On the right-hand side, you can see the top 10 countries where institutions are receiving climate change research funding on Africa. And at the bottom there are Kenya and South Africa. They're the only African countries that make it into the top 10 list of countries that host institutions receiving the lion's share of climate change research funding on Africa. And so this is a problem, I think, and it's something that we should be addressing going forward in terms of capacity building and research finance flows. One caveat to this analysis is that the South African National Research Foundation is the only government agency that is funding agency in Africa that's captured in these totals. And so we might be missing some funding flows from other African government national agencies, but it's expected that those would not substantially change this picture. And so this is a map showing the distribution of funding for research focused on different African countries, that is on climate change. So highlighting that this is the research, a lot of it is focusing on South Africa, Kenya, Tanzania, Ethiopia, and Ghana. Again, much of this research funding could actually be going to, well, is going to institutions outside of Africa, say in the United States, but they are then partnering with or doing research on South African ecosystems or Ghanaian food systems or Ethiopian food systems, for example. North Africa receives very little research funding on climate change, and Central Africa also receives a very low amount. When we look at the distribution of research funding across key sectors and climate risks, about an equal 40% of climate research funding is focused on climate change impacts and climate change adaptation, much less on mitigation. This is an interesting contrast from actual development project funding, where over half of the development project funding is going to mitigation and much less to adaptation. So research is the opposite of that. We would argue that increasing the mitigation research share might be something that is important to do, because this could help prevent African countries becoming large emitters in the future. The large focus on adaptation is encouraging because that's also in line with a lot of African country priorities on adaptation, given the risks that the continent faces. Most of the research funding has gone to food systems, climate change research funding to food systems and ecosystems. There's been much less targeted at poverty and livelihoods, health, cities and urban areas, and security and conflict, all of which have been identified in previous climate change reports as key potential risk areas for Africa under future climate change. And so in conclusion, we have more climate finance in Africa flows to mitigation compared to adaptation, but this varies widely by country. Again, South Africa and Egypt, for example, a lot of mitigation, Uganda, a lot of adaptation as a proportion of the country total. Disbursement ratios are concerningly low. This is especially the case for adaptation finance, suggesting problems with implementation. Climate change research funding on Africa has been increasing, which is good news, especially for climate impacts and adaptation, not for mitigation though. The lion's share of this funding goes to institutions based outside Africa. And given the scale of risks facing Africa, we'd propose a goal that in this research that amounts of climate change research funding for institutions in Africa should be at least equal to that for institutions based outside the continent, to create a more equitable distribution of research resources for understanding African climate change risks and solutions. Thanks very much. I'm happy to answer any questions now, or again, anything in the chat. Are there any questions on the climate research side?
Yes, I have a question. My name is Jackson.
Hi, Jackson.
Yeah, I'm fine, thanks. So I'm just wondering what definition of adaptation are you using, and therefore adaptation, climate change adaptation finance, because that's of course contested. Different institutions, different actors define adaptation differently, and of course there has also been quite a lot of challenges trying to distinguish adaptation from development. Thank you.
Sure. Yeah, that's an important nuance to this research. So for the development finance, the climate-related finance part in the first part of the talk, that definition of adaptation is identified by the funders. So we didn't apply a specific adaptation definition. It's just whether the organization that's providing the funding, for example, the World Bank or the African Development Bank, tags that project as adaptation, and then we included it as adaptation. So in the OECD database, things are primarily adaptation or mitigation, and that's tagged by the funder. So there could be some projects there that might not fit a consistent definition, but it's if the funder identified it. And then in the research financing, it was actually reading through the abstracts of the research proposals that were funded, and based on whether the authors of the research proposal had identified that they were doing a climate change adaptation or a mitigation or an impacts project, then it was included that way. So in both cases, it was whether the authors of the research proposal or whether the funders identified it as adaptation and not our own definition.
Thank you.
Okay, there's a question from Jessica before we go to the next.
Hi, Christopher, I have a question.
Sorry, it's actually, sorry, the phone is under Jessica. My name is actually Paula.
Okay.
Yeah, I've got, can you please, can you make a comment? I was also doing some basic research on climate change. And from my understanding is that adaptation measures mostly are measured to have an impact at local level or national level. And that's where national governments have make actually quite a few, some of their own contributions and commitments, okay? Where the mitigation, countries don't have, African countries, so at least I've looked at the SADC region, they don't have the capacity, so they depend on the contributions for which the rich countries have committed themselves in terms of skills, technology, funds, etc. But the reason why mitigation is mostly attracting most of the investments, it's because that's where the private sector, the big multinationals are coming and making profits out of it. So they're not really interested in adaptation measures, because whether the mitigation measures are supposed to have a great impact at global level. Have you got anything to comment about this? Thank you.
Yeah, that's important to highlight. So the research I presented did not look at funding from corporate and private sector. It was from multilateral and bilateral financing groups. So for example, the World Bank, the African Development Bank, or bilateral development aid agency from individual countries like Germany, Canada, the United States. So if we'd included private finance, the expectation would be that bias towards mitigation would be much higher. You're right, there's not a lot of private finance that's flowing to adaptation. Much more of it is going to mitigation. So the picture I presented shows that even for those organizations that are focused mostly around development aid, there's still a bias towards mitigation, which might be okay. We're not making a judgment on whether that's good or bad. But if we included private finance, it would be even much, much more towards mitigation. Some estimates as much as 9-1. So I'm conscious of time. I see there's a question from Edmund and Justice. Both of you had questions. I'm very happy to answer those, but I'll have to do it in the chat so we can make sure we get to our next presenter on time, which is Michelle.
Thanks, Chris. That was a very interesting presentation. It's quite a bit of a mismatch with all these different projects following on each other, but it's interesting. So my name is Michelle North, and I'm really grateful for this opportunity to present to you the results of our study on the risk of heat stress to cattle production globally. Firstly, just to provide a very short background on heat stress in livestock, both temperature and humidity together, as well as a few other things like solar radiation and wind speed, impair the ability of an animal to lose body heat. Increasing body temperature under hot conditions can lead to discomfort, reduce production, and can ultimately even lead to death. Different species, breeds, and even individual animals can have different susceptibility to heat through differences in their production of body heat. For example, milk cows with very high metabolic rates, or their ability to lose heat. For example, in these two boys that I've got on the right here, the one on the left is a classic Bos indicus or zebu bull with short reflective hair coat and a large body surface area. If you compare him with the European style Bos taurus bull on the right, who is perfectly adapted to withstand cold weather. There are also different management practices that farmers routinely apply that can reduce the susceptibility of their animals to heat stress. However, despite the fact that all these other things are well known, the current global extent of heat stress conditions is still not known. In addition to the future heat hazards and the magnitudes of impacts under alternative climate and socioeconomic pathways. I'm not going to go into details for the methods in this presentation for fear of running over time. However, please note that we use two main methods for this study. A comprehensive review of the literature on heat stress in livestock, which was then complemented by the modeling of current and future heat stress under different climate change scenarios. It is also important to note that we only focused on heat stress and did not account for the effects of climate change on areas that currently experience cold stress. If you want more information on the methods, please, you can follow this barcode on the right here. I'll also present it again at the end for our preprint. From the literature review, we found over 1,000 records on livestock heat stress in Web of Science. After screening, over 300 papers were included, of which 225 were about cattle. So from then on, we decided to focus the study on cattle so that we had the comprehensive data set that was comparable. Of these 225, 45 studies reported impact thresholds. If you look at this graph of studies over time, you can see that most of the impacts were to production, of which the vast majority were about the impacts of heat stress on milk yield. The studies that we ended up including in our data set covered a wide range of countries and different impacts, although unfortunately the only studies on heat-related deaths were in Europe. However, there was a glaring shortage of studies from the warmest parts of the world that are already most impacted by heat stress. If we revisit this chart of the studies we reviewed, those in the gray categorized exposures according to established thresholds, such as the Livestock Weather Safety Index. However, when we extracted the onset or break points from studies that reported linear impacts of heat stress on production, fertility, or mortality, we found that most impacts started occurring well below these commonly reported thresholds. We therefore used the median threshold THI of 69, or approximately the blue production line on this graph, for all further analyses. Currently, around 77% of cattle are exposed to climatic conditions that are likely to cause heat stress for at least 30 days every year, with cattle in the tropics exposed to heat stress conditions year-round. If we compare how heat stress changes by the end of the century under two possible world futures, we can see that while a world featuring low human population growth, large reductions in emissions, stringent environmental protections, and a shift in focus from economic growth to human well-being shows a distinct increase in heat stress days, the increase in heat stress duration under a regional rivalry scenario is overwhelmingly worse, with much of the world featuring at least 100 days of heat stress conditions every year. Severity of heat stress is another way of looking at the issue. This is sort of like the difference between a 40°C day and a 30° day if your comfortable temperature is 21 degrees. While both days are over your comfort threshold, there's still an enormous difference between 40 degrees and 30 degrees. Once again, we see that heat stress will be worse by the end of the century, particularly under the regional rivalry scenario. What is particularly pertinent is the fact that this shows the number of THI units over threshold on hot days. If you think back to the last set of maps, you can see that not only will tropical regions experience year-round heat stress, but every day will be on average more than 10 units over the heat stress threshold for cattle. Many regions currently have both high severity of heat stress and high cattle densities. When we compare the change in exposure as measured as increases in cattle populations in different countries on the y-axis, with the increase in heat in those same countries on the x-axis, we can see that under the regional rivalry scenario, expansion of cattle production is projected to occur in many of the same regions and countries where heat stress is projected to be increasing the most. With this chart, we are trying to tease out the relative contribution of increasing temperatures versus increasing numbers of cattle on the risk of heat stress. As you can see, in the Middle East and Africa, changes in cattle exposure to heat due to future land use decisions and associated changes in livestock numbers is the most important driver of risk. Heat stress reduces many of the factors that make livestock farming a viable business enterprise. For example, if we look at milk yield, since that was the one measure of production with the most comprehensive data available, we can see that by 2050, global milk production is projected to decline by about 35 million tons under a high emission scenario, and by about 22 million tons under a low emission scenario. So to conclude, adaptation of livestock farming systems to heat is essential even under current conditions. There are many different methods that farmers already use to adapt to heat that include management strategies to reduce the production of heat within the animal, provision of shade and other cooling systems, and choice of the most heat-adapted animals, breeds, or species. However, future land use decisions and development pathways must consider heat stress because the expansion of cattle into tropical forest regions is unsustainable, both by hastening the progression of climate change and increasing exposure of these cattle to severe year-round heat stress. In the absence of transitions to more sustainable food production and consumption pathways, increasing demands for livestock protein combined with climate change will undermine the productivity and welfare of hundreds of millions of cattle exposed to severe heat stress. Thank you. I would just like to acknowledge our funders on the right there. If you have any detailed questions, please feel free to email me and I can pass you on to the relevant or the most knowledgeable co-author. Also, you can scan this barcode to access a copy of the preprint of our submitted paper, and we have the more detailed results and methods contained there. Thanks.
Thank you very much, Michelle. We have 5 minutes for questions. Are there any questions for Michelle in the chat? I see, Michelle, there's a question from Joyce in the chat about what describes the regional rivalry scenario, what characteristics?
Thank you, Joyce. That's a very good question. I included it in one of the slides. So the regional rivalry scenario is a combination of the socioeconomic pathway 5, RCP 8.5, and it includes a world where there is high population growth in developing regions, high greenhouse gas emissions. There's uneven cooperation among countries for addressing environmental concerns. And this is the scenario where livestock production is projected to increase really substantially. I hope that helps.
Yeah, thanks, Michelle. There's also a question from Nora asking if Portuguese and Spanish literature on livestock was considered.
So Nora, we did have a few Portuguese and Spanish papers that made it through, and thanks to Google Translate, we were able to review them. So yes, we did include some Portuguese and Spanish literature, but they were the minority, unfortunately. But I think it was because we used Web of Science, and Web of Science doesn't, unfortunately, index very much non-English literature. But that is a discussion for another day.
Thanks, Michelle. Are there any other questions for Michelle? We have time for another one before we move to our last speaker.
If no one has a question, just to comment to Nora. Also, there were a lot of studies from Brazil and Chile and different areas, but if they didn't report linear impacts, they weren't included. So it's not that there isn't literature, it just isn't the kind of literature that we needed to use.
Okay. Michelle, thanks so much. Again, it's great to see the chat's really active with people's questions and comments. please ask questions of Michelle in the chat, or if you want access to preprints, Michelle can post that information. Michelle, thanks so much. And we'll move to our last speaker, who is Luxon Zvobjo.
Thank you, Chris. Can I share my screen?
Yes, please.
Okay.
Okay, we can see that.
Okay, thank you. Thank you so much. So, hello, everyone, and thank you for joining this fruitful discussion. My name is Luxon. I'm a PhD student at UCT, and also as I'm a co-chapter scientist for Working Group 2, Chapter 9. So what I'm going to share today with you the key findings from our draft paper on the meta review of the evidence of human adaptation to climate change risks in Africa, focusing on indigenous knowledge for climate adaptation in the African water sector. So this is a draft paper that is still under development, and to my left is these are the contributing authors. So just to give a bit of background on why indigenous knowledge and local knowledge in Africa and in the water sector. So there's growing interest on the role of IKLK in Africa and how this knowledge is informing communities' responses to the climate change impacts and across Africa. And there's so much published literature on IKLK of late that is highlighting the role of IKLK in many sectors. So this is a background on the data source that we used in our study. So we used the GAMI data set, which Portia alluded to earlier, which is the Global Adaptation Mapping Initiative that was developed by Working Group 2 members of the IPCC. So documents that we considered in this meta review analysis is documents that are indexed in the Web of Science, Scopus, and Medline. And to retrieve these documents, they undergo under supervised machine learning techniques with the assistance of humans. And more than 2,000, almost 2,032 articles were globally retrieved and screened, and they were all deemed potential eligible for data extraction. And to narrow down to Africa, about 324 articles were retrieved that were published between 2013 and 2020. So this is the methodology that we used. Over 20 coders were involved in this work for the Africa chapter or Africa documents. And for our analysis, we follow the systematic methodology by James 2016. And going forward, after we retrieved the 324 articles, key question that coders were answering that is relevant to this research was, is there any evidence of IKLK provided in the article? So in every adaptation measure that is listed in the article, there was a question to refer on, is there any evidence of IKLK is indicated in the article? And this coding was, it was a double coding. At least 2 coders were involved in coding one article. Then for data extraction and thematic analysis, we use NVivo. And from our preliminary NVivo results, we got 45 articles that were documenting the evidence of climate change adaptation practice in the water sector. And out of the 324, we then identified about 104 articles that were showing evidence of at least one water adaptation measure for the 5 main climatic hazards across the multi sectors. And these were distributed in 33 African countries. So this is what we find. And what I'm presenting here is the level 1 of our findings. So on this map, first to take note is the color gray is representing where we have evidence of water sector adaptation, or where we have at least literature. And then the white color is representing where we don't have any information or any evidence. And this does not mean that there are no researches, but probably they were out of our data sets we use, because we only focused on main 3 data sets. So from this map, the dots, the dots are showing where we have the studies, and the size of the dot is representing the number of studies. So the smaller the dot, the fewer the number for evidence we have. And from this map, we can show that West Africa and East Africa, we have relatively high researches in terms of water sector adaptation. Also similar to Southern Africa as well. So from our findings, we come up with 4 major classes. And the first class is water adaptation measures that are implemented in agriculture. Then we have the domestic or potable water adaptation measures. And we have group number 3, which is ecosystem-based and wetland restoration measures. And lastly, we have large-scale grey water infrastructure development. Just to go deep into the results. So here is the evidence of the adaptation measures across the sectors. As you can see, that in agriculture, irrigation is dominant, and also followed by rainwater harvesting. And these were mainly field in situ measures, and followed by water conservation. Then for domestic, it was mainly also rainwater harvesting, and these were mostly measures to do with how individuals or households are harnessing rainwater from rooftops and all other technologies. And the third cluster is the large scale. Here is mostly government initiatives or government approach, which is the large scale infrastructure in terms of irrigation and grey infrastructure, which is dams, and also the construction of potable water supply systems. Then the last group is ecosystem-based, which is mostly nature-based and wetland restoration measures. And in this group, we find that agroforestry was the dominant activity in the, activities to do with wetland restoration, as well as how communities are using agroforestry to recharge groundwater or to replenish groundwater. Then moving to the last part of our findings on what is the relevance of IKLK in the water adaptation. So from all the measures that we identified in the previous slide, we found that more than 60% of these measures were autonomous adaptation measures, and these were usually influenced by the IKLK knowledge that communities possess. And from this, our key finding was there is lack of formal recognition of IKLK by the government as well as the policymakers. And this is going to be addressed in the next slide. So yeah, before I move on to the role of government, here is what we found on the water adaptation limits from what is documented. So our main key takeaway was lack of human capacity is the main challenge that is facing many communities, particularly the smallholder farmers, in terms of implementing some of the water measures, water and water conservation measures, such as construction of different water conservation techniques. Also the construction of irrigation infrastructure, as well as the operation of these, which are labor intensive, and most smallholder farmers don't have enough labor. There's also lack of finances, which is these communities, they lack collateral security in terms of obtaining loans. And there's also high costs that are associated with the procurement of water harvesting, which was the main water adaptation strategy. And that left many communities vulnerable. And there were also gender issues that were limiting. For example, in other areas, you could find that women were not allowed to, for example, use a certain mode of transport to go and fetch water when there is water shortage. Then in trying to link with the indigenous knowledge as well as government or planned adaptation, we then assess the NDCs, the first NDCs that were submitted to UNFCCC. So we retrieved the 55 NDCs. And from these, we then also do thematic content analysis. So we were focusing on, we're only focusing on water goals or water targets. So we came up with two main targets, which is the water governance priorities. And the other one is grey water infrastructure. So we were assessing if in every country, are there water governance priorities as well as the grey water infrastructure. And to link with our study, we went on to check if there is any evidence of IKLK targets or priorities, as well as any form of recognition of this knowledge. And it's interesting to note that for all the 55 NDCs that were submitted, I mean, in the first round, we only found one country that had formally recognized IKLK, despite its major role that is playing in informing adaptation at a household or communal level. So here is our conclusions. We have two main conclusions or takeaways, which is number one, there's lack of evidence in the literature that we assess in terms of the efficacy of these current water adaptation measures that are implemented across Africa. And from our NDC's analysis, it confirmed the hypothesis that IKLK is still not formally recognized by governments and policymakers. And that is a huge gap that we think maybe in future, there is going to be the integration of indigenous knowledge with planned adaptation approaches. So with this, I end my presentation. Thank you.
Thank you, Luxon. Thank you very much for that detailed explanation of Indigenous local knowledge in the water sector. We have time for some questions. Please raise a hand or put questions in the chat for Luxon. Luxon, there's a question in the chat from Adunya. And that is what you think some of the, what you think some of the reasons, I think I'm interpreting it as what you think some of the reasons are behind the low government recognition of Indigenous knowledge, local knowledge in climate change adaptation.
I think maybe probably it's because of lack of policies that that formally recognize this kind of knowledge. Because if you are to go with the policies that currently used or that are currently in across Africa, you would find that there is limited connection between the policies we have and the recognition of local knowledge. So probably there is need to shift, there's need for a shift in terms of trying to integrate both the science knowledge or Western knowledge with the local knowledge.
Thanks, Luxon. There's a question about if you could define, a last question, in a little more detail, what you regarded as recognition of Indigenous and local knowledge, how you characterize that or define it.
So by recognition, we're simply noting whether for a particular country, whether they are formally associating themselves with Indigenous knowledge that communities are practicing. Say, for example, the use of certain tree species to predict water or to predict season quality against what the governments are giving out as a formal weather forecasting. So you'd find out that communities, they rely on such knowledge that they use and they perceive it to be reliable. And now the government is giving out what also they think is the reliable source. So by recognition is, we are just simply checking if the government, when they are giving out the information, are they also considering this kind of knowledge that communities are using?
Thank you,
be it in water management.
Oh, sorry, Luxon, I interrupted.
To climate change impacts.
Thank you, Luxon. Thank you, everyone, for attending. We've come up to the end of our time now. Claire from the ACDI has posted in the chat that the webinar recording will be uploaded tomorrow to the ACDI YouTube channel. So if there's anyone you know who think might be interested in what we were talking about today or this discussion, please point them to that direction. Or if you would like to go back and see a particular presentation or slide again, you can find it there. Thanks again to all of our presenters. for presenting their work in progress, and we're looking forward to seeing it out in journals in the near future. So thank you to all our African early career researchers. Thank you to our funders, IDRC and FCDO, hosts at ACDI, and thank you everyone for joining us today. We really enjoyed the conversation. Thank you.